Hello, everyone. I want to start off by thanking everyone that watched my past video and answered the questions. I really appreciate that. Hope everyone did well on their test. I'm going to go over today just a few real-life examples of matrix, what they can be used for, a couple word problems, things like that, so you can see applications of how you could use this. So the first example I'm going to be going over is, I am sure a lot of you have had classes where teachers grade things on a different scale, like your test will be worth more than your homework, etc. This is an example of how you can use matrix to see how they get to your final grade. So if we look at this example, if the teacher has 4 different areas of grading, the tests are worth 40% of the final grade, homework worth 20%, 25%, quizzes worth 20, and some projects worth the last 15%. If we look at 3 sample students, Adam, Megan, and Britt, if Adam has scored 92 on his tests, 100 on projects, 89 on homework, 80 on quizzes, Megan scoring 72 on tests, 85 on projects, 80 on homework, and 75 on quizzes. And then Britt has 88 on tests, 78 on projects, 85 on homework, and 92 on quizzes. We can use this information to set up a matrix with the different students. And so obviously this could be even longer. And in the areas they're graded on, tests, projects, homework, quizzes. And then we put in what they've gotten in those areas into the matrix. So we have this, we could have taken this from a table as well, implemented into a matrix. A lot of computer systems, like you could have an Excel spreadsheet that has all the grades, convert them into a matrix, and then we're multiplying that by 0.4, so this is for the 40% on the tests, 15% for the projects, 25% for the homework, and the 20% for the quizzes. When you multiply this out, so remember for matrix multiplication, we have the 92 times 0.4 plus the 100 times 0.15, etc. We do that for the first row here. And then the second row to get this Megan's, doing each student's. And then that total result we get here will be their final grade. So you can then see that this is how a teacher can get to your final grade. And then this will also always be able to be multiplied no matter how many different areas they're being graded on, because for every column that you add in this first matrix, you'll add another row based on the percentage. Hopefully that makes sense. So this example is for grades, but this can also be used to see any kind of percentage. All right, another example we have here is you can use multiplication as well to find best ratios. This example is for like nutrition. If we look at a combination of almonds, cashews, and pecans with their protein values for each nut, carbs and fat, looking at this table, all right, so that we see the differences in each one. If we have different mixtures, so like let's say like a trail mix, you want to find the best nutritional value. If we have these 3 different mixtures so like this is mixture number 1 with 6 cups of almonds, 3 cups of cashews, and 1 cup of pecans. The second mixture with 3 cups of almonds, 6 cups of cashews, and 1 cup of pecans. And this third one with 3 cups of almonds, 1 cup of cashews, and 6 cups of pecans. We can use these tables and convert them into different matrices. So this is for that first table. So we have the proteins, the carbs, the fats, the almonds, the cashews, and the pecans. And this is going to be multiplied. You can see here when they're next to each other that it's going to be the almonds being multiplied by the proteins of the almonds. So the number of cups of it multiplied by its value into each of these spots. I didn't show the steps for this one, but these are your end results. So you have to be careful though, when you do multiplication, to look for some things that you might have to change at the end. So in this example, this is per cup. And as you can see in each mixture, we have 10 total cups. So you actually have to divide by 10 from all our outputs to get our total nutritional values. So for the first mixture, the combination is 23.03 protein, 2147 for number 2, etc. So you can see like number 3 would have the most fat, so if you'd want to avoid that, potentially. Here we have the most protein. All right. So this is an example for nutrition, but again, same with like the other thing, these similar steps can be used for all sorts of different things. So another interesting thing about matrices is you can actually use it to find the area of a triangle and a few other shapes. Obviously, we know how to find an area of a triangle, but if we have maybe not the easiest way to find their length and height, if you have your points, so for here we have 3, 8, -2, 5, and 0, -1. If you put these into a matrix with the coordinates, so 3, 8, -2, 5, 0, -1, we're adding 1 into this column because for finding the area, we need to find the determinant, and we have to remember that you need a square matrix to find determinant. And so the area of the triangle is going to be 1/2 of the determinant of this matrix. The area always is positive, and so that's why we have this plus and minus, because based on how you make this matrix. So here we went right to left, but if we went the other way, we would probably get, I believe we would get a negative determinant. And so you would just obviously multiply by a -1. You could also look at it by finding the absolute value of 1/2 of the determinant. Whatever is easier for you. But this is how you'd get the area of the triangle. I'm not positive if you've done the determinant for larger than 2 by 2 matrices, but if not, I'll try to briefly explain it. So we have in the matrix, there is a plus, minus, plus, and then same with going down. So when you find the determinant, you have to find so you pick a column or a row that you want to go down. It can be any one, but for this example, the easiest one would be going down this column, number 1. You take this number, your first number, and you multiply it by the determinant of, sorry, let me see if I can write on here. All right, so if you remove the row and the column of that number, so you have the 5, 1, -1, 1 left. You multiply the 3 by the determinant of that, and then you move on down to the next number, and you would add, but in this case, you subtract because it is in a minus column, or sorry, minus row. But we have a -2, so we have minus a negative number, so this is going to be added, but it's the 2 with, you remove the row and the row and the column that the -2 is in, leaving us with the 8, 1, -1, and 1. So you multiply the determinant of that matrix by the -2. And then lastly, we'd have this 0, remove the row and column, giving us the 8, 1, 5, 1. But it's going to be multiplied by 0, so we know right away that this value is going to be 0. So the determinant of this matrix, now that we have a 2 by 2, we know that we multiply this diagonal minus the other diagonal, which would be a -1, giving us 6 here. So 6 times 3 is 18 for the value here. The determinant of this matrix, 8 minus a -1, we have 9. Multiplied by the -2 is -18. We now subtract the -18, so we add 18 to equal 36. But remember that we need 1/2. So we would take the 38 divided by 2, leaving us with an area of 18. All right, hopefully that makes sense. If anyone has any questions about going over finding the determinant of a matrix larger than 2, feel free to ask a question, and I could do another video on just that in case this wasn't very clear, those steps. But I'm just also pointing out that you can use that information to and apply it to different things like finding the area of a triangle. I'm not going over examples because it is something that a lot of you will do if you keep working with matrices. There's more complex things like you can find the electric circuits, the values of the amount of electricity going in and out. It's also used for finding the population of people, so you can set up equations for over time how much is adding to the population, also with how much is losing from the population. It's often used for profits. This percentage, you kind of can take this similar process of multiplication to find that. You can see how much your inventory is worth if these were all different objects that you have. And then you can also go by the profit or the cost of your item. So there is a lot of different applications you can have on this. All right, I hope everyone did well on their test. If anyone had a problem on one of their tests that they would like to see similar questions like that, again, feel free to ask. And I hope everyone has a great Thanksgiving weekend. Bye.